And that's what you're going to need to use in order to do the fitting aspect of things. So let me get that set up so that I can go through and show you how that part works. If you haven't already downloaded the instructions for that, go ahead and do so now. Okay, so my CoCalc screen likely looks a little bit different than yours, but it's probably relatively similar. And that's because I have the instructor version of things. So once you log in to CoCalc and work yourselves down into our Jupyter folder, you should now see the 4 files, one for each of the moons, as well as this file right here. So this is our Python program that we're going to go through and use to do the next bit. So you don't need to worry about downloading the files anymore for the moons. I've already got that done. So there's some various questions, but to go through and do the fitting, we're basically going to follow the instructions inside this, it's called a Jupyter Notebook. So there's various instructions that goes through here. And every once in a while you run into something like this. In order to run it, you need to hit Shift Enter. And so that'll go through and run things. In this particular one, there's no output. So if you continue reading, and I'm going to skip along a little bit, the main function of this program is to go through and fit the data that we have for this. And we'll add in the last one. So now when I do the Shift Enter and scroll down, I can see that I've got my, the blue curve is my fit. So you can definitely see that there were some measurements that were taken that were not correct, but most of them are following along this line right here. So the things that you need to record for your answer sheet are these numbers right here. So this R final, that's the distance in pixels from the moon to Jupiter at its furthest away point. The period is in days, so that's how many days it takes that moon to orbit Jupiter once. And this offset is essentially, when you start taking the images, it's not necessarily at its closest point or its furthest point. So that offset is just essentially offsetting things a little bit to make sure everything fits. So it's kind of like, how many days into its cycle did we actually start taking these images at? So we didn't start taking it at the beginning of its cycle. We started taking it at 0.7 days into its cycle. Now, sometimes, especially if you leave your code sitting around for a little while, let me see if I can undo running something. I'm going to purposely force something to happen so that we can see. So you don't need to do that part. But if you happen to try and run something and get an error that looks like this, name error, name NP not defined, if you see that at all, what that means is you need to go up here to this top one and run this again, because it's either timed out or you've been sitting too long or something. But what that's telling us is that it's not recognizing this library that we've defined in the first one. So now that I have run that, if I rerun this, it'll come up with no problems. So that's definitely something that pops up a lot. At this point, all of the files should be good. There was an issue for a little while with an extra character in the IO file. I believe I have fixed that by uploading all of the files myself. So if you run into a different error message, send me a message on Slack and I can go in and see each of your code individually and figure out what's going on. But I believe I have fixed that problem for everyone. So you'll go through, follow this through, do that for each of the moons given. You've got various questions to answer in your instructions. So if we go through and scan in the instructions, so you'll go through and do the Callisto ones like I just did. You'll answer some questions. You'll go back and do the same thing for Ganymede and Io, except you will need to start with your own guesses and see what the final values are. And then after that, you go through and actually use the measurements that you took to be able to calculate the mass of Jupiter. So astronomers would start with this one. I've gone through and already plugged in the values for some of these constants, like the G, the gravitational constant, and rearrange things for you. So you're going to use this equation both for here, when you actually calculate the mass of Jupiter for, based on the measurements from each of your moons, and make sure you show your work so I can see if there's any math errors, as well as there's a question down here for Europa that says to use the equation from question 4. That's this version of it. Make sure this is the one that you're using, because I've already plugged in the constants and things like that for you. And then there'll be some questions about your results from Europa, and that's the end of the Jupyter Lab. So if you have any issues with how your math is going, I can go through and check that. Any issues with your code other than that name error that I just mentioned, send me a message on Slack and I'm happy to help you through it.